Hi everyone, so today we're going to look at trig ratios and apply the ratios when solving certain problems. Now, trig or trigonometry is the study of the relationships among the side and the angles of a right triangle. And when we look at these ratios, what we're doing is we're comparing the side lengths of a right triangle. So here, given a triangle, and the little symbol that you see is the Greek letter theta. So we usually use that to represent an angle that we're trying to find instead of using x. So now let's go ahead and label our triangle. Now, the side that is opposite of the 90-degree or the right angle is called our hypotenuse. The side that is opposite of our angle is called the opposite side. And the side that is right next to the angle is our adjacent side. So let's go ahead and use these sides to go ahead and see what's the ratio, what's the comparison of our side lengths for sine, cosine, and tangent. So with sine, what we're doing is we're comparing the opposite side over the hypotenuse side. So there's our first ratio. The second trig function is cosine, so that is the adjacent side over the hypotenuse side. And then the last one is tangent, so that is the opposite over the adjacent side. So that's probably where you might have heard the acronym SOH CAH TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now what you're going to see here is three other trig functions. Now these functions are just the reciprocal functions of sine, cosine, and tangent, which means all we're doing is taking our ratios and just flipping those fractions over. So we're going to have hypotenuse over opposite, hypotenuse over adjacent, and then adjacent over opposite. So let's use these functions and ratios to go ahead and answer different types of questions given a right triangle. Okay, so let's use SOH CAH TOA to go ahead and find the exact values of the 6 trig functions given your triangle. So the first thing you want to do is go ahead and label your sides in reference to that angle. So we have opposite, adjacent, and hypotenuse. Now if you notice, you only have 2 out of the 3 sides of your triangle, so what we will want to do is use the Pythagorean theorem, where A and B are the legs and C is the hypotenuse, or the longest side. So plug in the information that you do know, 4 and 7. Use the algebra to go ahead and isolate A, get A by itself, and then we get square root of 33. So we're going to leave the adjacent side as the square root of 33. Well, now that you have all 3 sides, we can go ahead and use SOH CAH TOA to figure out what is our sine, cosine, and tangent. So sine was the opposite over hypotenuse, so 4 over 7. Cosine was the adjacent over the hypotenuse, and tangent was the opposite over adjacent. Well, now that I've used SOH CAH TOA, I can go ahead and say I have my 3 other functions, which were cosecant, secant, and cotangent. These were the reciprocal, so I'm going to take the 3 ratios that I wrote and just flip my fractions around. 7 over 4, 7 over square root of 33, and then square root of 33 over 4. Now in this example, we have a triangle, but you don't actually know what side is what. So nothing is labeled for us. So what we can use is, again, use our sine, cosine, tangent, or SOH CAH TOA, and then you can go ahead and see, well, sine is opposite over hypotenuse. So in reference to angle theta, I can label my side as 3 and 5. We know that secant is the reciprocal of cosine. So what we're going to have to do is we're going to have to find the hypotenuse and the adjacent side. Now we can use our Pythagorean theorem to find that missing side. You also know that it is 4 if you remember what your Pythagorean triples are. So you have a 3, 4, 5 triangle. So my adjacent side is my 4. Now secant is hypotenuse over adjacent, so I have my hypotenuse, which was 5, and then I found my 4, so my answer for secant of theta is going to be 5 over 4. Now in our second triangle, we know cosine is adjacent over hypotenuse, so I could label my triangle as my adjacent as 3, hypotenuse of 4. Now, this is not the same as a 3, 4, 5 triangle because in a 3, 4, 5 triangle, the hypotenuse should be the longest side, which it's not. Now, you will have to do the Pythagorean theorem to find your missing side. So here we go. We can plug in the information that we know, doing a little math and algebra, taking the square root of b. So my opposite side is going to be the square root of 7. Now I want to find tangent, which is opposite over adjacent, so I can plug in the square root of 7, and then I have my adjacent side, which was 3. So here are some settings that we want to make sure we have in our calculator before we do the next several problems. Now we want to be in degree mode, so go ahead and click on the mode button, which is right next to the second button. And then you will see about the third or fourth row down, depending on the calculator you have, you're going to see one word as radian and the word right next to it as degree. So you're going to click on the right arrow, so that way the degree word is kind of highlighted in black, and then you're going to press enter, so that way our setting can be changed to degrees. Now you want to know where the buttons are for these trig functions on your calculator. So what you'll see is that you have 2 rows above your 7, 8, and 9 buttons, the words for sine, cosine, and tangent. So you have the 3 main functions right in a row right next to each other. So sine, cosine, and tangent. Okay, so for these questions, we want to solve for x. We are actually going to be given an angle now. So in letter A, we have angle 24. So we can use the same ideas as we did in previous problems and figure out what sides we are given. So you have the adjacent side and the hypotenuse side. So think about which trig ratio that is. That is cosine. So I can set up my trig ratio with the cosine of my angle that I'm given now, which is 24. And again, set up a ratio, which is 31 over x, which you don't know what it is. That's your hypotenuse. So what you can do is you can say, hey, well, I can kind of put this in a proportion, put it over 1, and I can cross multiply. So I can have x times the cosine of 24. Notice that I keep my degree and my cosine together is equal to 1 times 31, which is just 31. I want to solve for x, so I have to divide both sides by the cosine of 24. Notice that I'm not only just dividing by 24, I'm dividing by the cosine of 24. So now when you plug that in your calculator as 31 divided by the cosine of 24, you get 33.9. So that is the length of your hypotenuse side. So here in letter B, I have 58 degrees. So in reference to 58, I have an opposite side and a hypotenuse side. I know that's my sine. So I can set up that trig ratio. Sine of 58 is equal to opposite over hypotenuse, so x over 18. I can put it over 1. I have a proportion, cross multiply. So I have x is equal to 18 times the sine of 58. Notice I'm not doing 18 times 58 and taking the sine of that. I am saying that I have 18 and then I'm taking sine of 58 and multiplying those two together. So I will get 15.3. Now, in the next two problems, what we're going to do is we are going to actually find missing angles. So when you're solving for a missing angle, we actually use the inverse of the appropriate trig function that we are trying to find. So you're only using the inverse trig functions when you are trying to solve for a missing angle. What you will see is that you have little notations, right, with that little -1, but it's sine inverse, cosine inverse, or tan inverse of your angle theta. So how we get our inverse is same button, sine, cosine, tangent, just right before that, I'm going to press the second button. I'm going to press second, and then I'm going to press whatever my appropriate trig function is. So second sine, or second cosine, or second tangent. Now with these two examples, again, let's go ahead and find that angle. So first, let's see what sides we have. We have an opposite side and we have an adjacent side in reference to that angle we are trying to find. So I know that's tangent. So tangent of some angle I'm trying to find is opposite over adjacent, so 30 over 18. I want to find x, so I have to do the inverse of the function I have. So I have the tan inverse. So in order to find x, right, that inverse trig function is going to undo the tan function that I have. So tan inverse of 30 over 18. When I plug that in my calculator, I get 59.0, and it's in degrees because this is the angle that I'm trying to find. In letter B, I have my angle actually at the top of my triangle, but same thing, I have hypotenuse and I have adjacent. So my hypotenuse and adjacent I have as cosine. So cosine of x is equal to 30 over 50. I want to find my angle, so I have to do the inverse. So inverse cosine of 30 over 50, and that gets me an angle of 53.1 degrees. Now here are some things for you to remember. Always make sure your calculator is in degree mode, and then also you only use the inverse trig functions when you are trying to find a missing angle. Now I hope this video was helpful and you learned how to evaluate the 6 trig functions of a right triangle. Thanks for watching and see you next time!